Hello my dear students, welcome to the session. In the last session we have started fundamentals, the problems on fundamentals, and let's continue with the problems here, the classroom workbook. Now 23 problem we have already done, it is still there on the board. Now let's go with the 24, classroom workbook 24. So let's see here. Now let's find power of each element, that is power supplied or absorbed by each element. This is 8 volt, 2 ampere, minus 4 ampere, 10 volts, minus 3 ampere. Okay, this is what given actually here. Okay, now let's find power of each element. Okay, all of you just make an attempt. Okay, so to find the power, say this is P1 again, P2, P3, P4, and let's say this is P5. So what is P1? Voltage source and current source both are connected in series here, right? Okay, both are connected in series. So you know the current through this element, but you do not know what is the voltage across it. Yes or no, all of you? You know the current in this, but you do not know the voltage here. Current source, current is known, but voltage is to be determined. Voltage source, voltage is known, current is to be determined. To find the current here, already the current is there, but what is the voltage here? See this, you can apply jumping technique anywhere. Not only that particular case I explained you, but here also you can apply. If this is 0, what is the voltage here? 10 volts. Yes or no? Jump from this point to this point. What is the voltage? You're jumping from higher potential to lower potential. When you jump from higher potential to lower potential, you drop the voltage. So what is the remaining voltage? 2 volts simply. So P1 is equal to 2 into 2. Current is leaving from positive because what is the voltage now here? 2 minus 0. 2 minus 0 means this is plus, this is minus. Current is leaving from positive. Therefore, it is supplied power. Next, P2. 8 into 2 because they are in series. 16 watt. 16 watt. Current is entering into negative. Nothing but leaving from positive. Okay. Therefore, supplied power. Now, P3. P3. Minus 4 into 10. Minus 40 watt. Minus 40 watt. Polarities please, plus minus, because 10 minus 0, plus minus. Leaving from positive. Supplied power. Minus 40 watt supplied power is nothing but plus 40 watt absorbed power. P4. What is P4? You know the voltage, but you need to find the current. To find the current in any path, I told you already. If there is a resistor, apply Ohm's law. If there is no resistor, just simply apply KCL. So this path doesn't have any resistor. Let us apply KCL at this node. Or at this node also you can apply. Let us apply here. What is the current coming here? 2 ampere. What is the current here? Minus 4 ampere. What is the current here? Minus 3 ampere. So totally minus 3, minus 4, that is minus 7, plus 2. Total how much coming here? Minus 5 is coming. Minus 5 is entering, then minus 5 should leave. I'm just giving here minus 3, minus 4, plus 2. That's it. So minus 5 into 10. Minus 50 watt. Absorbed power. Nothing but plus 50 watt. Supplied power. Coming here. Coming to this one now. This is 10 volts. Then this is also 10 volts. This is 0 already. All these elements are parallel only, right? So therefore this is plus, this is minus 10 volt. Current is still leaving from positive, again supplied power. but that is a negative value, yes or no? Minus 3 into 10 will give you minus 30 watt. That is supplied power. But now plus 30 watt will be absorbed power. Yes or no? See, some of the powers, if you see, 4 plus 16, how much it is? 20. 20 plus 50, how much it is? 70. That is supplied power. Here 40 absorbed, 30 absorbed, total 70 absorbed. Total power supplied is equal to total power absorbed. So power got balanced according to Tellion's law. Okay? So please note down this. Note on that. Meanwhile, I just note another problem. Classroom workbook, question number 25. This was actually asked in GATE. Okay, now let's start with 25th problem. Please, all of you read this question. In your workbook, please go to question number 25. In the interconnection of ideal sources shown in the figure, it is known that the 60-volt source is absorbing power. Okay, the 60-volt source is absorbing power. 60-volt source is absorbing power. Which of the following can be the value of the current source capital I? Which of the following can be the value of current source capital I? That's the question. Okay. So please look at that diagram, all of you. The question is very clear and the data is very clear. It is known that 60-volt source is absorbing the power. Then which of the following can be? I think you understand the meaning of it. Can be means what? Possible. Okay. Which of the following is a possible value? Okay, for capital I. Do that, all of you. Just go through the question once again. I think all of you understand that question, okay? Well, now let us see. This is what the current I. To find the current I think either you apply Kirchhoff's current law here or here, doesn't matter, anywhere it is okay. To know the current here, you must know current here as well as here. You already know the current here, yes or no? But do you know what is the current flowing here? You do not know that, right? But already he is saying that 60-volt source is absorbing the power. What is the data given? 60-volt source is absorbing the power. So to absorb the power, or for any source to absorb the power, what should be the relation between the current direction and polarities of the voltage? The current should enter into the positive terminal, right? So therefore, say this is some I1. Let us assume that this is I1. And I1 should be a positive value. If I1 is a positive value, then only the 60-volt source will absorb the power that is given in the data. It must always absorb the power. It is known that it is absorbing the power. So I1 should be positive value. Yes or no? Now let us try to choose. Okay, let us try to choose the current from these given options so that this is going to absorb the power. First, let us proceed conceptual without having these 4 options, because sometimes without options also you must be in a position to answer the questions. Sometimes the questions are framed only based on the options. But let us try to look at the concept first, because tomorrow you may get a question in a different dimension. You may not get the same question, right? So therefore, look at this. I plus I1 is equal to 12. Do you have any objection if I write like this? Because current I1, current I, and is equal to what? 12 ampere. This is the equation 1, let us say. Okay. You do not know I. You also do not know I1. A single equation, two unknowns. Okay. The single equation, two unknowns. The right answer for this question is there is no unique answer or unique solution. Unique solution for capital I as well as I1. Without knowing I1, I cannot find I. Without knowing I cannot find I1. That's it. Okay. If somebody is giving this question without any options, then answer this question. The answer must be what? No unique solution for it. I cannot say there are multiple answers. Or you can say without I1, I cannot find I. That's it. But what is the question mentioned here? Please read it out. Which of the following can be the value? Can be. That means what? There is no unique solution means there are multiple solutions. Yes or no? No unique solution means multiple solutions. Okay? In that multiple solutions, one of the solutions may be coinciding here in the given options. Understand? So let us see that. What is that actually? Look at this, all of you. If I choose this 18 ampere, what could be the I1 value here? Suppose if I choose I is equal to 18 ampere. 18 minus 12, that is 6 amperes flowing upward, but I1 will be minus 6 ampere. Okay? I1 will be minus 3 ampere. I1 will be minus 1 ampere. I1 will be, what is that? Plus 2 ampere. Look at this. Okay? Multiple solutions are there. No unique solution means multiple solutions. In that multiple solutions, probably one among them will be existing, right? Yes or no? Look at this. This is a positive value. Actually, the data given that 60 volt source is absorbing the power, then for that, definitely the current I1 should be a positive value and should enter into positive terminal. Therefore, this is the only answer correct. You understand, all of you? Okay. You can also conclude from this particular one that not only 10 amperes, but any value that is less than 12. Look at this. This is greater than 12, greater than 12, greater than 12. But this is less than 12. Not only 10 amperes, but any value, because multiple solutions. No unique solution means multiple solutions. Any value that is less than 12 ampere will definitely make the 60 volt source absorbing the power. Please write on that. Note. First you write on this, then I will tell you the note. Okay, important note. So why I am elaborating this explanation, to understand the concept first, because tomorrow you may get the question in the different dimension. Don't think that the question will come in the same dimension, but the concept is same. Please note down that quickly, and note you can write. In the given problem, any value for capital I, any value for capital I, any value for capital I that is less than 12 ampere, any value for capital I that is less than 12 ampere will make 60 volt source absorbing the power. absorbing the power. So question number 26 in your classroom workbook. Determine the value of E. Determine the value of E. Determine the value of E. You can easily do that. Please try. I'll give you meanwhile another question here. Some gate questions we are seeing now. Okay, I think all of you got the answer right. It's very simple. Some 4 options were given. Okay, but I think you don't need the options. Directly you can attack the problem. And always, practice without any option. The previous problem is something different. There, you definitely require options. That is purely options based question. The earlier question what I was talking about, 25th problem. Okay, but this problem doesn't require any option. Directly you can straight away find it, right? So E value. From here 0 is given. Here we do not know, so let us not come from this side. Here we do not know V1, let us not come from this side. But you can come here 0, jump from this point to this point. What will happen? Higher potential to lower potential. Drop the voltage or take the voltage? Drop the voltage. So 0 minus 1 is minus 1 volt. Jump from lower potential to higher potential. Take the voltage. So 10 plus 5, 15 volt. This is plus, this is minus. That means you must assume this is greater. This is greater. So therefore E can be written as minus 1 minus 15. That is minus 16 volt. Okay, it's very simple problem. Very simple problem. Now coming to the 27th problem. Please take the 27th problem. Read that question given in classroom workbook. Finish that, all of you. Okay, it's a very simple one. 27th problem. Read that question here. The 2 electrical subnetworks N1 and N2 are connected through 3 resistors as shown in the figure. Okay. The voltage across 5 ohm resistor and 1 ohm resistor are given to be 10 volt and 1 volt respectively. Then the voltage across 15 ohm is. Then the voltage across 15 ohm is. Okay. So he is asking what is the voltage across 15 ohm. If I give an options, give the options, then probably you can easily recognize it. But let us practice the questions without any options, because nowadays you're getting more than 60% of the questions are fill in the blanks in the gate. So let us not rely on or depend on the options. Okay. All of you please make an attempt. Meanwhile I'll note down another problem. Okay. First you make an attempt. Anyway, I will explain. Do not worry about that. But your attempt is very important. Okay. Whether you get a right answer or wrong answer doesn't matter. Your attempt is important than getting an answer. Work. Look at this, all of you. What is given actually here? Voltage across this, and you need to find the voltage across this. Okay. This is subnetwork. N1, N2 are given as subnetwork. Subnetworks means what? You have some elements. Network, subnetwork. System, subsystem. Subsystem is a combination of certain elements. Okay. System is a combination of subsystems. So finally, system is a combination of elements only, no doubt. Okay. So here, N1 and N2 are two subnetworks which consist of certain elements. We do not know what are the elements connected here and here. And we do not know how those elements are connected, whether series, parallel, or we do not know. What type of elements they are, we do not know. How they are connected, we do not know. Okay. So these two are the subnetworks. But we need to find the voltage across it. Definitely all these elements, you cannot say they are in parallel or series, something like that. You cannot say, because we do not know the combination here. Yes or no? Okay. Therefore, we do not know the combination, but we need to find the voltage across this. How do you find? Look at this, all of you. When you have a network something like this, for example, because this is a known concept, nothing new here. Look at this. Suppose if I say this is 3 ampere. We do not know what are the elements connected here and how they are connected, but what could be the current coming out here? 3 amperes. Yes or no? In the written path also you get the same current. Current entering is 3 ampere, current leaving from the network is what? 3 ampere. That means what? Indirectly, you are actually satisfying the Kirchhoff's current law. This network is treated as a node, let us say. At node, 3 amperes is entering, 3 amperes is coming out, leaving. So KCL is satisfied. Yes or no? Therefore, students, you must understand the same thing here also. Suppose instead of 2 wires, if I take 3 wires, let us say, what will happen? This is 0 ampere. Now suppose this is 2 ampere, then this is going to be what? 1 ampere. 3 amperes is entering, 1 plus 2, 3 amperes is leaving, therefore the KCL is satisfied. Yes or no here? Therefore let us do the same thing here also. Now, look at this. To find the voltage across it, you must know current here. But for that, you must know current here. Already given the data, 10 by 5 is how much? 2 ampere. 5 by 1, how much? 5 ampere. 2 ampere and 5 ampere. 2 plus 5 is entering, treating this particular network, subnetwork as a node, let us assume that. Because just now we have explained. At subnetwork, KCL must be satisfied. Okay. Now 7 amperes entering, then 7 amperes must leave here. 7 amperes must leave here. Therefore, now look at this. Look at this. This is 15 ohm. How much here? 7 ampere is entering. Okay. 7 into 15. How much here? With the polarities plus and minus. 15 into 7. You get 105 volts, right? But these are the polarities because of your current direction. The current direction decides the polarities. But how you are measuring the voltage? You require, your desired polarities are like this. This is what the voltage. So therefore, V15 ohm, the desired polarities are in mismatch with what the actual polarities. I can say minus 105 volts. I think all of you understand. Please note down. Please note on that. Meanwhile, we'll go for question number 28. I think all of you noted on that. Let's go for 28th problem. In the recent gate, the similar network but with a slight modification it was asked. All are 6 ohms. Note down all of you once again. It is already there in your classroom workbook, but still note down quickly. Note down quickly. It is already there in your workbook, okay? I think all of you understand this problem, right? 27th problem is very clear. In 27th problem, you write one point better. Because tomorrow you may again come across the same scenario. Let us draw one conclusion. Note, 27th problem, okay? Please put a note and write down. Please put a note and write down. Later we will go with this problem. Please put a note and write down. At every subnetwork, KCL must be satisfied. At every subnetwork, KCL must be satisfied. At every subnetwork, KCL must be satisfied. Okay, I think all of you written that. Then let's go for this problem. At every subnetwork, KCL must be satisfied. That is the important concept. Okay. So ultimately, you have to remember the statement: at every subnetwork, KCL must be satisfied. Okay, I think all of you noted down this. It is still there in your classroom workbook. Okay. Now let's find the RAB. What is the value of resistance across AB terminals? Okay. First, looking at the network. Okay. Just see how we can simplify it easily. And most of the people, they have a habit of, whenever they find delta, they convert it to star. Whenever they find star, they convert to delta. Without looking at whether it is really required or not. You understand? If you require, then only you go for it. Otherwise, don't go for it. Okay. So look at this. There are certain cases like, here, if you see, for example, these two are in series. 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 Yes or no? Okay. Series combination. And for this, you don't require star delta transformation. Yes or no? So first, let us simplify this. 6 plus 6, 12. 12 parallel 6. How much it is? This is 12 ohm, but 12 parallel 6, how much it is? 4 ohm. So I think you understand, between these 2 points, I can replace these 3 elements. Okay? There is no need to apply star delta transformation for these 3 because these 2 are in series, then parallel over. But here, these 2 are neither series nor parallel. I cannot really simplify them. These 2 are neither series nor parallel. I cannot simplify them. But I can simplify this, and this, and this. And finally, I can get, okay, what is this value here? I'm getting 4 ohm. That means this is 4 ohm means this entire combination is replaced by simply what? 4 ohm. Similarly, this one also replaced by what? 4 ohm. This one also replaced by what? 4 ohm. And this one is also replaced by what? 4 ohm. That's it. Yes or no, all of you? Okay. Now, this is 4 ohm. This is also 4 ohm. And here also it is 4 ohm. And here also it's 4 ohm. Understand all of you? Okay. Now, this 4 ohm and this 4 ohm, how they are connected? They are in series. This 4 ohm and this 4 ohm, how they are connected? They are also in series. Yes or no? Okay. Therefore, look at this. It looks like something like this here. It looks something like this. It looks something like this. Two ohm, 6 ohm, 6 ohm and 6 ohm. 6 ohm, 6 ohm and 6 ohm. This is 4 plus 4. How much it is? 8 ohm. Here also 4 plus 4 ohm. How much it is? 8 ohm. In fact, in the recent year, in the gate, this exact network was given with different numericals. The same structure, same physical structure was given in the recent year. Okay, but now I have just extended this actually. This looks very interesting problem. Now, AB. Look at this, how you are able to simplify. Once you simplify this, okay, then you got all these things. Understand all of you? First, when the network is given, your focus must be on whether we can simplify using normal reduction, series parallel. Is there any possibility or not? First, you have to check that. Without checking that, you suddenly jump into started transformation, even though it is not required. Unnecessarily, you invite all complications, and finally, you may not get the right answer. I'm telling you. Okay. So, first step, whether we can simplify without applying star delta. If it is unavoidable, then we have to go for. Look at this case now. After drawing this, now we understand that it is unavoidable. Neither series nor parallel. Neither series nor parallel. All elements are neither series nor parallel. You have to go for star data transformation. Okay. Now let me apply star data transformation for this because equal values are there. Better, I think I prefer. Okay. Like this. What is this? 6 by 3. This is 2. This is also 2. And this is also 2. Here also same 6 by 3 because delta to star, right? 6 by 3, 2. This is also 2. This is also 2. Now you tell me what's happening here. This 2 ohm is in series with this 2 once you cut down these elements, right? And this 2 ohm is in series with this. This 2 ohm is in series with this. Yes or no? Yes or no? This 2 ohm is also in series with this. This 2 ohm is in series with this. Yes or no? This 2 ohm is left and this is connected to B. Now, what's happening here? This 2 plus 8 plus 2 you will get. Yes or no? It's something like this. Look at this. Let me draw it again. So what is this? 2, 2, 2, 2, 4, not 4, 8, right? 8 and 2, 8, 2 and this is 2. Look at this. 2 plus 8 plus 2. How much it is? Okay, 12. This is 12 ohm. This is also 12 ohm. Okay. Now 12 and 12 parallel. How much it is? 6. 12 parallel 12. How much it is? 12 parallel 12. 6. Now 6 plus, this is 2. Okay. This is 2. This is also 2. How much it is totally? 12 ohm resistance. This is what your answer. Okay. Yes, and all of you, I think is very clear that please note down quickly. Okay. Whenever you are applying reduction, first you check. The first important step to check is whether we can use a normal series parallel reduction. If it is unavoidable, then we'll go for what? Star delta transformation. Okay. So I think you have noted down this, right? This part. So please go for that. Meanwhile, I just note down another problem here, okay? So always try to generalize how to solve the network instead of just try to remember the network, okay? If you try to remember the network, then you will be in trouble. You need to generalize. If this network is given, how to solve. If this is the situation, how to solve. You have to draw certain conclusions and generalize always. '29 problem classroom work. This was also asked in GATE. So what is the question actually 29? The voltage V in the following figure is always equal to. Okay, so all of you please go to the question number 29. I think you have done this, right? Finish that all of you. Okay, let's go with that now. Question number 29. Question number 29. Question number 29. Okay. Read the question. The voltage V in the following figure is always equal to. The voltage V in the following figure is always equal to. Okay. Look at the options given: 9 volt, 5 volt, 1 volt, and none. Okay. So generally, how do you find the voltage? To find the voltage, you need to apply KVL. Yes or no? Wherever you want the voltage between 2 points, you need to apply the KVL. Of course, for KVL, we put a different name that you can apply touching concept. Touching concept is also nothing but KVL. Yes or no? So let us apply the touching concept. To apply the touching concept here, from plus to minus when you go, you must require voltage across each and every element. What is the voltage here? 5 volts. What is the voltage here? I need to know current, but already current source is there. Therefore, can I say this is plus minus 4 volts? Yes or no? All of you? Current is flowing here, right? Plus to minus. Okay, polarities are decided based on the direction of current. But do you know what is the voltage across this current source? Directly or indirectly, any information is given? No. Okay, for current source, you know the current, you need to know you know the current, you need to find the voltage. But you don't have any information regarding the voltage across this. Say randomly some plus minus Vx, let us assume. Sir, how you are taking plus minus polarities? I do not know, just I am taking randomly. If you don't like, you take minus plus also, doesn't matter. Okay, I'm just assuming that there is some voltage across the current source with certain polarities, that's it. Now, if I write V is equal to plus Vx plus 4 plus 5, okay. So, this is what an equation that you got. Understand all of you? One equation but two unknowns. One equation but two unknowns, there is no unique solution. There is no unique solution. I think the similar scenario we got in the previous problems, right? Okay, we also got the same scenario in the previous problem. I think I can refer that problem also. Okay, that is 25th problem. In 25th problem also we got this I plus I1 is equal to 12 ampere. No unique solution. But in that particular case, it is mentioned clearly that the 60 volt source is absorbing the power. Then which of the following can be the value? But here he doesn't mention anything. And he is asking the V value is always equal to. You understand? A single equation, two unknowns, that means there are multiple solutions for V, and in that multiple solutions, without knowing this Vx value, can you find this V value now? It is not possible. Therefore, the answer is what? None. You're supposed to choose. You're supposed to choose what? None answer. Now you can write one thing here that, okay, since Vx value or voltage across the current source is not known. Since voltage across current source is not known. Across current source is not known. It is not possible. Write down, it is not possible to find V. It is not possible to find V. You understand all of you, okay? So this is how you need to solve the problem. And I make a small modification in this problem. For example, okay, you can call it some 29A, let us say. Okay, this is not given in the classroom workbook, but I am extending the problem here. Look at this. If in the above problem, if power supplied by 2 ampere source is 12 watt, then what is the value of V? Suppose the question is given like this. Look at this, how simple it is now to find. Power of 2 amperes is 12 volt. That is Vx into 2 will be what? 12. Then what is the Vx value actually here? Vx is going to be what? 6 volt. And what could be the polarities of this particular voltage? See, look at this. This is what the current source. Now this is what actually the voltage source already given. And this is what the V you need to find. Okay. And here, since it is supplying, the power supplied, when do you say this current source supplying the power? What polarities are supposed to be taken here? Plus, minus. How much it is? 6 volt. This is 2 ampere given. How much voltage you got already here? 2 into 2, 4 volts. Then the voltage V can be determined as what? V is equal to, now minus 6 plus 4. And what about this? Plus 5. Then plus 5 here. Then what do you get here? Minus 6. So minus 1. Therefore, this is 3 volts. So if the power is given, then you can find. But in the problem, the power is not given. He simply mentioned that find the V value, and V is always equal to, just like that he mentioned, it is not possible unless we know the value of Vx. But in this problem 29A, you can just calculate like this, because tomorrow you may change the problem. Okay. So therefore, please note down this.